All right, so we are going to look at the connection between the graph and the equation for ellipses and circles today. So first, looking at the ellipse, and the ellipse is basically like an oval, and there are kind of some features that we're going to be able to tell from the equation. So first of all, this is just my center of the ellipse, right in the middle, and then we're going to figure out how much we need to count up and down and left and right to figure out where that ellipse is at. So a few things on the picture here. That's the center of the ellipse. We call whichever side is longer, so either horizontally or vertically, we call those the axes. Whichever is longer, we call the major axis. Whichever is shorter, we call the minor axis. So sometimes the vertical axis will be the major, sometimes it'll be the minor. It just depends on which one is longer. Also then, we have this distance here. So from the center out to this point, we say is A. Same idea vertically. So it's basically just half of each axis. We call this one B. And those tie in directly to the equation here. So in this equation, we have x minus h squared over a squared plus y minus k squared over b squared. And it's always equal to 1. So a few things we're going to get from this standard form is the center of our ellipse is going to be at hk. The other things then we need from the equation, we already know a and b are going to be our distance from the center to kind of the edge of that ellipse, both horizontally and vertically. We also have something on ellipse called the foci, which is just plural of focus, which are these X marks here on the graph. So the foci, so C is distance from the center to foci along the major axis. Those are those 2 points that can be used to construct the ellipse. C then comes from this formula. So using a squared and b squared, which are the numbers on the bottom of the fraction. So we'll look at standard form for the circle here. A circle is a lot more basic. Really the only thing you need for the circle is the center and the radius, which we'll call r. So you'll notice the standard form looks similar to the ellipse. We have the x minus h squared and the y plus k squared. This time, though, the circle is not just equal to 1, it's equal to whatever the radius is squared. So the only two things we need for a circle is that the center is at hk, and the radius is just r. Those are the only two things we need to graph a circle. So we're going to go through a few of the things in the rest of this packet here to kind of give you an idea, and you guys will finish the rest on your own then. So for the ellipses here, they give us some things to identify. We have the center, the length of the major and minor axes, the foci, and then we want to graph the ellipse and its foci. So to start, we're going to look at the center. So remember, the center comes from h and k. So those are the numbers being added or subtracted to x and y. So here we just have x squared. So my center is going to be at 0, and we just have y squared. So 0, 0. And that's coming from here and here. There's nothing with the x and the y, so my center is at 0, 0. So let's go ahead and plot our center. So the center is here. All right, so next, the number under the x is going to tell me how much to move left and right. So I take the square root of that number. The square root of 36 is 6, so I'm going to move 6 horizontally, and 6, so 6 left and 6 right, both horizontal. The amount I move up and down then comes from whatever is under the y. So 16, we always take the square root. The square root of 16 is 4. So vertically, I'm going to go 4 up and 4 down. This is then my ellipse. Okay? So a few of the other things we want to say. My major axis, so that's always going to be the longer one. Here the major axis would be horizontal because the ellipse is longer horizontally. And the length, I moved 6 left and 6 right, so that total length is just going to be 12. Same idea for my minor axis, that's the vertical axis. If I went 4 up and 4 down, total that would be 8. The foci then, so I'm going to come over here. I know foci is c squared equals a squared minus b squared, so 36 minus 16. So c squared is equal to 20. So c, we'll get an approximation for the square root of 20 here, is about 4.5. So to graph those, I'm going to go from my center and count over about 4.5. 1, 2, 3, 4.5, and just put my x there. And then I want to say what the coordinates of those foci are. So negative 4.5, 0 for the foci on the left, and positive 4.5, 0 for the foci on the right. All right, let's look at the next one here. So start the same way, my center. Here, my center is going to be at whatever these values are that go with the x and the y. So negative 5, 1, so they're in parentheses, so we can take the opposite. So I'm going to go ahead and graph that then. Right there is my center. Next thing that I need to figure out how much horizontally and vertically. So horizontally is the number that goes with the x. So I have an 81. The square root of 81 is 9. So I'm going to count 9 left and right. So I ran out of room. I'm going to have to put 2 more spaces over there. Vertically then, I'm going to look here. So 144 is under y. The square root of 144 is 12. So I'm going to count 12 up and down. So 1 above there. So then my ellipse looks like this. So then as I think of my major and minor axes, my major is going to be the vertical one here. I went 12 up and 12 down, so total that would be 24. My minor, I went 9 left and right, so total that would be 18. For the foci now, so I'm going to look at c squared is equal to, we're always going to take that bigger bottom number and subtract the smaller one, so 144 minus 81. So sometimes it's a squared minus b squared, sometimes it ends up being b squared minus a squared. 63, and the square root of 63 is approximately 7.9. So because my major axis is vertical this time, I'm going to count 7.9 up and down. There, and there. So when I write the coordinates, they both have an x-coordinate of negative 5 because that's where my center is at. And if I was at 1, and I went up 7.9, I would be at 8.9. If I was at 1 and I went down 7.9, I'd be at negative 6.9. All right, so I'll leave the rest of the ellipses there for you to graph. That's really the gist of it. So we're next going to look at number 6. So here they give you the ellipse and they want you to write the equation. So what I'm going to do is first figure out where my center is at. So here my center is 0, 0. So I know I'm just going to have x squared over something plus y squared over something, and an ellipse is always equal to 1. So I need to figure out what those numbers on bottom are. So to do that, I have to figure out how many am I counting left and right. So here I'm going right 2. 2 squared is 4. For the vertical part, then I'm going up 1, 2, 3. 3 squared is 9. So that would be my entire equation. So we'll leave the rest of the ellipses there for you to find the formula of. Next, we'll graph a circle here. So circles are actually the easiest conic sections to graph. You only need 2 things, a center and a radius. So as I look at the first one here, my center is going to come from these values. So my center is -1 and 2. So I'm going to graph that. My radius then comes from this value, and I'm going to take the square root. The square root of 9 is 3. So from my center, I'm going to count up 3, right 3, down 3, and left 3. And that makes my circle. And that's all there is to it for a circle, just center and radius. So I'll leave the rest of the circles there for you guys to try. We're going to now jump to number 15. So this page and the next page kind of have some, kind of the other way around. You're writing the equation based off of some of the features that they give you. So we'll try 15 together here. So write an equation of ellipse that has a major axis endpoints at 2, 2 and -4, 2, and minor axis endpoints at -1, 0 and -1, 4. So I'm going to start by plotting those points that they give me. So 2, 2, -4, 2, -1, 0, and -1, 4. So there's my little ellipse. So what I need here is to figure out where the center is at. So the center of all these points would be this dot here. So I can tell that my center is going to be at -1, 2. So you don't necessarily have to draw in the ellipse. I'm just using these points to help me figure out the equation. So from there, I know I'm going to have x plus 1 squared over something, plus y minus 2 squared over something, equals 1, because an ellipse is always equal to 1. And then I want to look from the center to the left or the right is 3 spaces, so this would be over 9. From the center up and down, it's 2 spaces, so 2 squared is 4. So that would be my equation there. All right, so I'll leave the other ellipse ones there for you to try. We're also going to try one of the circle ones, so I'm going to jump to 18. So diameter endpoints at 3, 5, and 11, 5. So let's graph those. 3, 5, and then 11, 5 is one off of the paper there. So basically my circle would be out here like this. So I'm going to again figure out where my center is. So if that's the endpoints of my circle, the center is just going to be right in the middle there. So right there. If that whole kind of line from end to end would be 8 long, I would have to go 4 over for the center. So my center is then at 7, 5, so I need the point of that center. So that tells me my equation is going to be x minus 7 squared plus y minus 5 squared equals, and now I also want to figure out what my radius is. So from the center out to either of those points is 4, and 4 squared is 16. So that would be the equation of my circle. So the rest of these I'll leave for you guys to try here.